solving polynomial equations and inequalities graphically. We've already done something similar with quadratic. Okay, so we've already done some of this. We're going to use our calculator sometimes. We're going to get to the point, we've already talked about how to graph a polynomial function. So we don't necessarily have to use our graph because we know some more our calculator, because we know a lot more properties right now. In any case, that graph is shown of f of x. Looks like a cubic polynomial function. And so we're asked some questions. So it says if f of x equals 0, the values of x where the graph, where are we looking basically? Where to find the solution? So if it's equal to 0, we're looking at, getting my pens to work. The x-intercepts of the function, okay, or the points on the x-axis, or the zeros of the function. So here, to complete the sentence correctly, the values of x, where the graph of f of x crosses or touches the x-axis. So in this case, that would be x equals, now we're estimating, we did one like this yesterday, it looks like negative 2.5, positive 1, positive 4. And you can use negative 5 over 2 as well, right? Where is the graph greater than 0? We want all the x values. So that's when we look for above. So all of this part here, not including those values because there's no equal sign, and all here. So the only thing different from quadratics is that there's more graph. So in this one, it would be x between, values of x where the graph of f of x is above the x-axis. So that's going to be from negative 2.5, 1, and greater than 4. Okay. Then the values of x where the graph is, so only thing different here, we've got an equal sign, is on or above the x-axis. And so only thing different here would be including the equal sign. All right, then less than, we're looking for below the x-axis. So that's going to be everything less than negative 2.5, and then everything between 1 and 4. The next card has an equal sign, so is on or below. So we just include the equal sign. Okay, so when we were solving quadratics like this was one quadratic, y equals, and then we compared, right? It's called f of x in this case. And we're looking for where those y values are compared to 0. Now, if we have two functions, and this is going to correspond to maybe using our graph, our calculator, where we graph the left side and the right side separately. Okay, and one of them is not 0. So if we do that, when we did that for solving, we would just find the points of intersection, right? But now we're asked, we may have inequalities where we're told f of x is greater than g of x. So what x values does that Okay, so graphs of y equals f of x, that's the solid one. G of x is the dotted. We want to do some solving here. So if we're trying to find where f of x equals g of x, that's where you look here. Okay. Notice how in this, it's all in terms of x, right? F of x, it would have x cubed plus something x squared, etc. G of x would be just something x squared. There's actually no y's in there. So you're looking for the values of x where the graph of f of x intersects the graph of g of x. Okay, we've done all this before. We're just being a little bit more formal, a little bit different notation in a sense. We're naming the functions. There's really nothing new from what we've done. So here, the solution, we're just looking for the x values. Okay, because it is a system in a sense, because we're putting it into our calculator or graphing it. But overall, that's what we're solving, only in terms of x. So here, x equals -3, -1, and 2. We just care about the x values at those points of intersection. Okay. So next one, what values of x give f of x values? So y values on f. I'm actually going to just to remind myself, label this f of x and this g of x, just to remind myself. So we're looking for all the x values where the solid one is greater than the dotted one for any particular x value. So for example, if I chose x equals -2, the y value for f of x is above the y value for g of x. It's greater. Okay, so that would work. Anywhere along here would work. Okay, because for any x value, it's above. If I look here for, say, x equals 0, then my g of x is above. So that part's not going to work in there until I get back here. And then this is above. And it would keep on going for all of these values. So we're looking for the values of x, where the graph of f of x is above the graph of g of x. Well, when does that occur? That's between -3 and -1 for x and greater than 2 for x. And then equal to is on or above. So we just put in an equal sign. Less than would be, we'll do it in red here. So this part, basically it's the opposite, right? So any parts that we haven't included. So that's where it's going to be below. So that's going to be x less than -3, or between -1 and 2. Okay. And only thing different is the equal sign, so on or below. And we include the equal sign. Okay, so we're just reviewing again how to solve this. That graph was given to you. They're not always going to be given to you. Sometimes it's the equation or the simplified form of it. Okay, so we're going to graph corresponding functions. Two methods. Method one, where we graph y equals the left-hand side, y equals the right-hand side. And method two, we won't get to that today, but that's where we put everything on one side. So take a look at what we're asked to solve here. Notice how there's no y's. We're just finding the values of x. Okay? Here, same thing. It's an inequality. Same left side and right side, but now an inequality. Same left side and right side, another inequality. So let's first do the values of x that satisfy the equation. So we've graphed the left side for you, and we've graphed the right side. Okay? Taking a look at this, we want to look at the intersection points. Okay, well, actually, we'll go through the steps. If in your calculator, you would graph the left side, so x squared minus 4x plus 1, and the right side, x plus 1, and they are shown there. So this would be y1, this is y2. Where do they intersect? So we've labeled, so the x values, if it's an equation, equal sign in there, are 0 and 5. If we're solving the inequality, then you need to look closely. This is your y1, this is your y2. So we're looking for where y1 is below y2. So y1 is above there, but it's below y2 there. So what x values for those points? We can, so that's going to be between 0 and 5. And no equal sign, so open circle and join those up. And so we would say that in a statement, x greater than 0, less than 5. And really, we've already done something like that, right? Because that's a quadratic and a linear. Okay, use the graph to estimate the solution to greater than or equal to. So where is y1 greater than or equal to? So here, including that, and here. Okay, so let's do it. We'll circle this way, we'll circle this way. So that's going to be x less than 0, x greater than 5. Okay, so we'll do question 4 because it uses your calculator so that we can get a little bit of practice in that. So now this is a cubic and a quadratic. We're going to do it in method 1, left side, right side. So we're not going to move anything over. So we're just going to keep the left side and keep the right side and put them into your graphing calculator. Oh, here, sorry. X cubed plus 2x squared minus x minus 7, and then negative x squared minus 4. I'm going to start with a standard screen. But now that we've learned some properties of polynomial functions, you want to think about what's that graph going to look like. So a cubic can only have a maximum of 2 turning points, and it's got 2. So there's not going to be any changes out here. And a quadratic is going to, in this case, open down. So we want to see that point of intersection there. Okay, I can see other 2. So I'm going to go to my window and make my y min maybe negative 20. Okay, so I've adjusted my window. I'm not gonna do a sketch. I'm just going to give the window here. So x, I said negative 10 to 10. Y, I went from negative 20 to 10. Okay, so now you can see those intersection points. And we are solving where the left side, the cubic, has to be less than or equal to the quadratic. So if you take a look here, cubic is blue on my calculator. So it would be this part here, and then this dip here, and that's it. Okay? So we need to know those intersection points. So second, trace, intersect. And you actually might want to sketch it just to help you remember all of it. Okay, so enter, enter, enter. That one's at negative 1 for x. X equals negative 1. I don't even care about the y, so I'm not even going to write it down because you might start giving the y to me. Intersect to get another point, so I'm going to go left. Negative 3. And this one here. What? X equals 1. Okay. So we turn to the next page. It says state the x values where they are equal. So negative 3, negative 1, and 1. And then solve. So where is it less than? Remember, the cubic has to be below, so it's this part here. So less than negative 3, and then between negative 1 and 1, including the equal signs. And then when we graph that, I'm just going to finish this question on time. Okay. That's good. You can even probably work ahead if you want. But this weekend, it's more about preparing for your cumulative. Okay, so okay, so next one, solve that. Again, actually this one's just a quadratic and a linear. So quadratic left side, linear right side. The inequality, same left side and right side. So calculator out, we're going to be an expert at this. By the time you're done, clear off your previous equations. 2x squared minus 4x minus 1. Oh, I put that into y2. I'm going to clear that in a second. In y1, I'm going to put the left side. Not that it matters, but and then negative 2x plus 3. Okay. Now, was there, yeah, so we're going to show all the steps. There's no prompts here, so the first thing is to state y1 equals y2 equals, then we'll state our window. And let's just see. So I'm going to go back to a standard window, because maybe you're doing this fresh after resetting your calculator, like on a test. Perfect. The standard window works, right? You can see both points of intersection. Okay. So I'm just going to call this step 3A. So this will be for A, and this will be B here. So for 3A, we're find the x values of the points of intersection. And for 3B, we're finding the x values of all the points where y1 is below y2. So let's do those. So let's find the intercepts first. So second trace intersect, enter, enter, enter. So that's -1. So here, core A is x equals -1. And what else? It looks like 2, but we'll have to actually do it. I'm going to have to cursor closer. And it is 2. Okay. In B, you don't really have to do any more work. I just have to look at the graphs. I'm looking for where y1, the quadratic, is below y2. So that would be in here, where that vertex is, right? So that's between -1 and +2. This. And there's no equal sign, so we don't include it. Oh, that's not what I want to do. Okay, question? So, method 2, rewriting the inequality so that the right-hand side is equal to 0. So in method 1, sometimes it's hard to get that window. So if you're not that comfortable with your calculator, you're going to be spending too much time finding your window. If you get everything to one side, then you know you're just looking on the x-axis. Not looking for a point way up here or way down here. So that's easier. You're only going to change your x window. You don't care about the y's in the second method here. Okay? Doesn't matter. We're not going to say, oh, solve this one by method 1 and this by method 2. You decide which method works. Now, in this method, though, you have to be able to add and subtract like terms, which hopefully at this level, 20-1, you can do that. But, you know, obviously, if you don't bring the terms over correctly, you're going to get, you're not going to get the right answer. Okay? So solve this inequality. We've got a cubic there, a quadratic there. It prompts you to rearrange the inequality so the right-hand side is equal to 0. So you're going to bring everything over. Sec. Good. So let's try that again. Bring everything over. So we're going to have x cubed 4x squared plus 3x squared is 7x squared. Negative 17x minus 3x is minus 20x. Negative 58 minus 38 is negative, what, 96, I think? Yep, greater than 0. Okay. Now you just graph the non-zero side. Get your calculator out. And then x cubed plus 7x squared minus 20x minus 96. Try a standard window. It's a cubit, so if you see 3x intercepts, you don't look anywhere else, right? I see 3, I don't care how high it goes or how low it goes in this method, right? Because I'm not looking for any other, there's no points of intersection, right? So you can sketch the graph in our window here. We're just using a standard window. State the roots of the equation. So you're finding those x-intercepts. Couple of ways of doing it. Second trace 0 feature. Enter on that. Okay, and then my cursor is at 0, negative 96, the y-intercept. I don't even see it. So I'm just going to cursor to the right until I see it, or you can just enter a value, but there I go. So to the left of where I think it is, enter. To the right, enter, enter. 4. Now, this one's kind of nice. If I had wanted to just test 4, you could. That's what I'm going to do on the next. It looks like it's at negative 3. If I'm in trace mode, which I am if I see my function there, if I enter negative 3, remember it assumes that's an x value. Enter on that, you get 0. You don't have to do any more of those big steps, right? If you get a y value of 0, that's an x-intercept. So what did I say? That was negative 3, and this was 4. Now, another way to do it is you could actually, and you don't have to enter this in terms of your work, but you could enter y2 equals 0, and that's really going to graph your x-intercept, or sorry, your x-axis. So you can find the intersection of those two graphs, which will end up being the x-intercepts. Now, I have one left to do, so I'm just going to cursor closer to that leftmost one. It's going to take a while, or you can enter a value, but there I just saw it. Enter, 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 and I get negative 8. Okay, so there's different ways on the TI. Castios are a little bit faster. Okay. So compare those two graphs. To solve the inequality, well, that's what I just did in the last one. We would determine the values of x where the blue graph is greater than, so that means above the x-axis. Right. So now let's show that solution. So that's going to be above the x-axis. So let's just look at it again. Sorry. So where is it above? Between there and there. And so between negative 8 and negative 3 and greater than 4. And then just graph it on a number line. one more, same deal. Let's do this last method where you get everything on one side. First thing, y1 equals. Second thing, window. Third thing, so we try that out. Values were on or below the x-axis. So that part and this part, I need the intersection points. So I'm going to graph that y2 equals 0 just to make it a little bit easier. Cursor goes to the next left one, that's -1. The next one looks like +1. If I enter +1, it is. Oh, that's on the red graph though. Actually, I want to be on the blue. Yeah, blue, 1, 0. Blue, it looks like 2, 3, 4, 0 as well. Okay. So -1, +1. So we want everything where x is less than -1 and between 1 and 4. So if you're having, so that's it for the lesson. If you're having any difficulty with your calculator, I'll come around and help. I forgot the equal signs here. There, that's better.